Okay, so there's quite a bit to question 7, so potentially quite a few points that would show up on our test here. So given a quadratic equation, we should be able to find things like its vertex, line of symmetry, its min or max value, domain range, y-intercept, be able to approximate the x-intercepts and then find the exact x-intercepts with quadratic formula, be able to describe when it's increasing, decreasing, constant, and then something called a tangent line at the vertex. So first off, I guess there's really, you could go in any order that you want to, but I'm basically going to go in order here just to pick one. So the vertex, if I was to move this into vertex form, which this one doesn't ask me to do, but you should have another question on your review somewhere that asks you to put it in vertex form. Vertex form looks like this, but the part that we need in this question is HK. So H comes from this, and K, whatever you get in this for this number, if you plug that number into the function, you get the y value. So for us, negative b would be 6 over 2 times a, which would be 2. So it looks like the vertex has a x value of 3. And then, so the y value is the y value when you plug in 3. So that would be 9 minus 18 plus 7. Looks like negative 2. So 3, negative 2 is our vertex. So this question gave you this formula and the directions. I would not assume that we would do that for you on the test. That's not the only way to find vertex, but it is probably the most direct path. So all parabolas could be cut in half. There's a line of symmetry that goes through them, and that line of symmetry has to go through the vertex, because that vertex is always up the middle. So that would be x equals 3. X equals because it's a vertical line. Okay, is this going to be a minimum value or a maximum value? Okay, how do you know that? Okay, how do you know it's opening up? Okay, so there is y-intercept, that's true. If you thought about the y-intercept, which we'll have to do at some point, then you're going to have the general shape of your graph, that's fine. What about using this a value though? If a is positive, the parabola opens up. If a was negative, it would have opened down. So if it's opening up, this bottom point is a minimum, which is good because it barely fits on our graph anyway. But the minimum value comes from the vertex. So it's not when is there a minimum value, not the x value, but what is the minimum value. Okay, let's go ahead and finish this graph because that will help us with some of these questions. So just like there's this line of symmetry here, I know that this point could be reflected over. So he's 3 away from the line of symmetry, so 3 away over here would give you another point. That's what they're calling a mirror point here. And depending on how accurate my graph needs to be, that's already a pretty good start. But parabolas go forever to the left and forever to the right, so the domain should be everything. Range is describing the y values. Looks like it goes down as far as negative 2. It hits negative 2, so you have to have a bracket, and then goes up forever, so infinity. Y-intercept I found earlier just because it helped us with something else, but y-intercepts always have an x value of 0. Plug in 0 into your function, 0 minus 0 plus 7. That's how I knew that that was 7. They ask us to approximate the x-intercepts, so I don't know, about 1.5 and 4.5. That would be my approximations, which, multiple choice, depending on the choices, that might be enough. But the only way to know for sure is quadratic formula. So quadratic formula will certainly be on your test. So if we plug these numbers in, opposite of b plus or minus square root b squared minus 4ac all over 2 times a, just like we practiced the other week or last week. As long as you know quadratic formula and you plug it in, it's usually not too big of a deal. Just be careful with the arithmetic and the discriminant. This would be 28. 36 minus 28 would be 8. And does the square root of 8 reduce?
Yes. 2 squared.
Okay, and so is that it? Very good. Remember, some quadratic formula questions you have to divide. If every term is divisible by the same thing, you need to divide them. So divide by 2, divide by 2, divide by 2. So it looks like the exact answers were 3 plus the square root of 2 and 3 minus the square root of 2. So if you want to throw those in your calculator to look at the decimals, I bet they're close to 1.5 and 4.5. But eyeballing it is often not very accurate. That's why we need quadratic formula. Okay, increasing values is where the graph is going up. So it looks like he starts going up at 3 and then goes up forever. Decreasing values is when your graph is going down. Always read left to right like you read a book. Looks like he starts going down from the far left and keeps going down till x equals 3. Parabolas never have a flat section. They're not going to have any constant. And then for the last part, tangent line, you have to remember that a tangent line is something that touches your graph at most one time. So that's more like a geometry term. So at the vertex, so this would be the tangent line. Tangent line is a very big concept in calculus because it's kind of like showing off the slope at that one instant. Okay, well, what is the slope there? What's the slope? 0, because it's a horizontal line. And looks like it always has a y value of -2. So the equation would be y equals -2. But you might want to write that out to the side in case it's on your test. Tangent line is the line that touches the graph exactly once. And at that time I made it touch at the vertex because that's what the question said.
Did you have it like going up and down on like the line of symmetry?
One more time.
Could you have the tangent line like being the axis of symmetry line? This is still being a tangent.
No, this isn't a tangent line. It does intercept the graph only at once, but tangent lines will always be on the outside. It's kind of like if you were just looking at a specific point and you were trying to draw the slope at that instant. So like right here, this would be its tangent line. Right here, this would be its tangent line. Those would be very hard equations to ask you to do, but this one, so it's always on the outside. But good question. Others from 7, because there's a lot of stuff there. Again, that could easily be 10, 20 points on your test. There's a lot of different parts.